This is example number 6 in stage 1 NEET lecture 1 competitive question. Conductivity of 0.002 molar acetic acid solution is 7.896 into 10 power minus 5 Siemens centimeter inverse. If lambda m, that is molar conductance at infinity dilution for acetic acid is 390.5 Siemens centimeter square mole inverse, what would be a dissociation constant? So to do this problem, what we should do initially, we need to understand that we need to connect certain formulas what we learned in the PU part. It is very simple, but little bit of calculations are involved in this. Now all of you know that lambda m is equal to K into 1000 divided by C, that is equal to 7.846 into 10 power minus 5 into 1000 divided by 0.00241. So ensure that all are in the same units. Simplify this, you are getting 32.5 Siemens centimeter square mole inverse. Next we have to calculate degree of dissociation. For that, what formula we learnt in the PU? Lambda m by lambda naught m. So what is lambda m? We found out in the previous step, 32.5 Siemens centimeter square mole inverse divided by lambda naught m is 390.5 Siemens centimeter square mole inverse. Now, so here what happens? The units gets cancelled. Therefore, we are having alpha is equal to 0.083. So this is the second step. So we have to go step by step. Next step is for acetic acid. Acetic acid is a weak acid. Acetic acid is a weak acid. Therefore, dissociation constant is Ka is equal to C alpha square by 1 minus alpha, that is 0.00241 into 0.083 whole square divided by 1 minus 0.083. So now you calculate this, you will get 1.81 into 10 power minus 5. So children, we are using 3 steps here basically. So this will be step 1, calculation of lambda m, then step 2, calculation of alpha, okay, then step 3, calculation of dissociation constant Ka.